This is section 1.2, misrepresenting data. We need to look at this graph here on the screen. We've got the same data represented in two different ways. So we need to, number one, ask how are the graphs the same? So they're the same because the graph and the data is exactly the same on both ones. Number two asks how are the graphs different? Well, we can see at the graph when we look at the numbers, it starts at 350 and goes up to 700. Where over here we have the graph going from 800 to 100, or to 0, 800 to 0. So the graph shows very different representation of the data, even though it's the same data over and over. Which graph gives a more accurate representation of the sales trend? We could say that the graph on the left shows a better representation of the sales because it's actually what's happening. It's over the last few months it's gone up, but not as drastically as it looks like in the graph on the right. So at the bottom right hand side you can see that here there's a little squiggle that that shows the break in the y-axis. So we can see that the break in the y-axis of a graph means the length of the axis has been shortened. So the break can be shown as this or as this. So when we distort a graph, when we're talking about that, we mean that we are changing the appearance or twist the meaning of something in a way that is usually misleading or often misleading. When we distort it, it is misleading. So here are some examples of distorting the scale. Matthew's math test scores are displayed on the bar graph. Matthew's math tests are the left here. The score, we can see that it's right here. We can see that it has a misrepresentation there. It's got the little break in the graph. So it starts at 60 and goes up to 70. So this is 10 degrees, or sorry, 10 marks. So according to the graph, what did Matthew receive on each test? On test 1, he received 60%. Test 2 is 65%. Test 3, 68. And test 4, 69. Question B, so from the graph, what appears to be true about Matthew's improvement over the 4 test scores? What appears to be true is that they're going up, and they're going up from 60 to 70. It looks like the graph, it looks like he's gone up double, triple, quadruple, saying like 5, maybe 6, 5.5 times his original score. When in fact, it's only gone up 9%. So what part of the graph has been distorted to create this impression is the bottom there, the marks. So it seems that Matt's improved greatly over the 4 tests. The break mark caused the results to be distorted. So he's only gone up 9%, even though it looks like he's gone from 20 to almost 100 if you times it by 5. So how should the graph be drawn to represent Matthew's progress more accurately? That's what the graph should look like. It should start at 0 because that way it gives an accurate representation of the graph. What's a more accurate conclusion about his improvement? It's been improving, but it hasn't been improving a large amount, just a small amount over the last 4. The improvement between test 1 and 2 was the greatest, and 3 and 4 with the least. So distorting the visual. From the pictographs on the left, which pet seems to be the favorite? So on the left, we look and we can see that right here, the fish is leading. So it looks like the fish is the number 1. So it's the longest and the symbol is the largest. From the pictograph, does it seem like more students like cats or dogs? Explain. Well, it looks like more people would like dogs because they're wider, they're longer, right? Dogs come out to here, where cats only come out to about here. So based on this graph, I would have to say dogs are more likable than cats are. So because it's longer. The pictograph should be redrawn with the same size symbol so you can see which one you could look at it and it could show you, the length would show you which one was the most favorite. We can also distort the size of bars, so you can see on the right hand side how many times more sales are there of desktops than laptops. Is this an accurate representation? Well, we can say yes, because they're the same graph. This time there's no shortness at the bottom, and it goes up to 4,000 on both of them, which is fantastic. That's what you want. However, when you look at these graphs, this one is very, very wide, where this one is very, very narrow. On the left, on the right-hand side, it looks like there's a lot more desktops sold than laptops, just because it's 4 times the size. From graph B, how many times more? How could graph B be misleading? Misleading because again, there's 2,000 here, there's 4,000 here, which is twice as much, but it looks like much more because of the width of the bar compared to this bar over here. So misrepresenting data used the ratio. The trucking company has been tracking its profit over several years. They displayed the data using a bar graph. Explain how this bar graph could be misleading. So first of all, we can see that it starts at 300 and goes to 600. So it looks like from 92 to 95, again, it looks like they've gone up an extreme amount. That's a very, very sharp gain. But again, it's only from 300 to 600, which means it's doubled. This does not look like it has doubled this. Not at all. So it starts at 0 or 300 instead of 0. What conclusion about the profits does the graph suggest? It suggests this gives me the impression that the profit in 92 was not as great as it had been in other years. This is what the graph should look like. So we can see, but it's now such a less steep line than the one before, and that's why it's an accurate representation, because it shows the whole graph. Describe how each of the following graphs are misleading. This graph is inconsistent, so when we look at this, there's big breaks in between. This one goes from 8 to, there's 8 spots here, there's 4 spots here where there's only 1 from everywhere else. So that's a big difference there. This barrel one is very tough to see. Sorry. This barrel one is very tough to see, but the image sizes are very distracting. When you see this at the front, this is very, very similar to this one, except, but it is a very tough graph to see. Baseball players' salary, salary of average American and average baseball player's salary. Again, the numbers in the bottom are, very inconsistent here. It's not showing a gradual time. It's jumping all over the place without equal representation. Is this graph going like this, or is it more like this, or is it more like this? We really don't know. There's no scale on the vertical axis here, so we don't know what numbers are over here. On the pounds of skim milk consumed per capita, again, this is a different size than this one here, and that really skews the data. And then massive increase in houses prices again this year. This is $2,000, but when you look at it, this looks like it's almost tripled, this difference here. And that's the end of our presentation, or our lesson. We'll see you in class tomorrow. That was the end of 1.2. There's another 1.3 coming up next.